Alright, so question number 5, we're being told to prove that sine. So now this is sine, and then there is a bracket. Inside the bracket we have 2 sine inverse of x plus cos inverse of x. Alright, so this is also an easy one. So the first step shall be to let a be equal to sine inverse of x, and we're going to let b to represent cos inverse of x. So basically now we can see that this will mean that sine of a is equal to x, and here we can see that it will mean that cos of b is equal to x. So now we can already see that when we put everything back, remember that we have this sine outside, so we're going to substitute this back. So where there is sine inverse of x, we shall put a, so we'll end up having sine into 2a plus b is equal to root of 1 minus x squared. So now this is what we have to prove. So we have proved that sine of 2a plus b shall give us root of 1 minus x squared. So now when we look at the left hand side, we can actually expand it. So when we expand it, we have sine 2a cos b plus sine b cos 2a. But we know that sine of 2a is the same as 2 sine a cos a, because this is a double angle, and then this double angle cos 2a shall be cos squared a minus sine squared a. So now this is what we end up having. So multiply this in and we have this. So we have 2 sine a cos b plus sine b cos squared a minus sine squared a. So now we are fortunate in this case, but there are some values and terms that we actually don't know what they represent. Now we know that sine a is x and we know that cos b is x, but we don't know what cos a represents, and we also don't know what sine of a represents. We know what sine of a represents, but we don't know what cos of a actually represents. So we need to find cos of a, and we also need to find sine of b right here. So those we can solve using right angle triangle. So this is what we have. So now where sine of a is x, now remember that we can represent that as x over 1. Now in a right angle triangle, that will mean that where we have an angle a, it means, because sine of a means opposite over hypotenuse, it will mean that the opposite is x and the hypotenuse is 1. So from Pythagoras theorem, we have a squared plus b squared is equal to c squared. We'll have a squared plus x squared is equal to 1 squared. And then a squared shall be equal to 1 squared minus x squared. And then a squared is 1 minus x squared, because 1 squared is 1. And then if we find the root of that, we can say that a is root of 1 minus x squared. So now we know what the adjacent value is. So if we know that, it means that therefore cos of a, which is basically we know cos is adjacent over hypotenuse, is going to be root of 1 minus x squared divided by 1, which can basically be represented as root of 1 minus x squared. So now where cos of b is equal to x, remember we can also represent that as x over 1. We can put that on a right angle triangle. Now cos of b simply means that we have adjacent, so the adjacent shall be equal to x and the hypotenuse is 1 from the knowledge of SOHCAHTOA. So we can see that the adjacent is x and the hypotenuse is 1. So from Pythagoras theorem, we'll have a squared plus b squared is equal to c squared, of which x squared plus b squared shall be equal to 1 squared. And then if we make b squared the subject, b squared shall be equal to 1 squared minus x squared, of which 1 squared is 1. So we have b squared being equal to 1 minus x squared. Then b shall be equal to root of 1 minus x squared. So now that we know that, it means, now we know the opposite value here. So it means that therefore sine of b is root of 1 minus x squared. Alright, so therefore when we substitute everything back in, we'll have this right here. Now next we can multiply the values, and we know that 2 times x shall be equal to 2x squared, then times this root of 1 minus x squared plus root of 1 minus x squared into the bracket. So you know the square of this, because there is a root here, this root shall cancel with that, and we'll be left with 1 minus x squared, then minus this x squared. And then the next step is, you can see that minus x squared minus x squared is going to be equal to negative 2x squared, as you can see right there. So the next step shall be to multiply this inside the bracket, and I'll have 2x squared into root of 1 minus x squared plus root of 1 minus x squared minus 2x squared times root of 1 minus x squared. Now the next step you can see is that this and this are actually exactly identical, so they will cancel, and I'll be left with root of 1 minus x squared. But you remember that you remember what a and b represent. So you remember that this shall be the same as this. Now remember that a represents sine inverse of x and b is cos inverse of x. So therefore sine of 2 into sine inverse of x plus cos inverse of x shall be equal to root of 1 minus x squared, and hence we've proved it.